Okay, gentlemen, we are going to start with 4.2, quadratic functions. If we look at example 1, we're going to start with something that you're familiar with, a little review here. In terms of the equation, f of x equals a negative quantity x plus 3 squared plus 1, we should know that our parent function is that x squared graph, and we're just going to focus on that point 0, 0. We know that the negative is telling us to flip over the x-axis. We know that this plus 3 is telling us to go left, and the plus 1 is telling us to shift up 1 unit. So our point that was at 0, 0, we're going to translate left first, flip over the x-axis, go up 1, and so our point 0, 0 now has moved to a negative 3, positive 1, and our graph is going down that way. In terms of our domain, we know we have no restrictions. We have no even roots to worry about. We have no variables in the denominator. So our domain is a negative infinity to infinity. Looking at our graph, we can see our range, our y values are going from a negative infinity up to a positive 1, including that positive 1. Minimum value, our lowest y, well, our graph is going towards a negative infinity, so there is not a specific minimum value. It does not exist. Our max value, the largest y, is our positive 1. Interval increasing, our graph is going up. Our y values are getting larger and larger as we move across the interval from a negative infinity to a negative 3. Interval decreasing, our graph is going down. Our y values are getting smaller as we move across the interval from a negative 3 towards a positive infinity. We're going to jump down to turning point. Turning point is where our graph switches from increasing to decreasing or decreasing to increasing. In this case, our turning point is the negative 3, 1. And on our quadratics, that turning point is what is referred to as the vertex. So our vertex is that turning point, is that negative 3, 1. We've talked about lines of symmetry. And with our quadratics, with our parabola, we have a specific line of symmetry that cuts right through the middle of our parabola. It goes right through that vertex point. It is a vertical line, and all vertical lines are x equals equations. So our equation for our axis of symmetry is the line x equal to a negative 3, x equal to the x value of our vertex, which was the negative 3. X-intercepts, we always set our y equal to 0, or in this case, f of x equal to 0. And so for our equation here, we would have 0 is equal to a negative x plus 3 quantity squared plus 1. If I bring my 1 over and then divide both sides by a negative, we're going to take a square root of both sides, and we know that a square root squared, we get the absolute value of that quantity. Square root of 1 is 1. Because of the absolute values, we know we're going to get that plus minus. That's where that plus minus is coming from. And so we get a negative 3 plus or minus 1 is equal to x. So a negative 3 plus 1, we get x equal to a negative 2, and a negative 3 minus 1, we get x equal to a negative 4. So we have two x-intercepts, one at a negative 2, 0, and one at a negative 4, 0. Y-intercepts, we know for y-intercepts, I know that we always set x equal to 0, and if we set x equal to 0, we're going to have f of 0, and in this case, our equation is going to be a negative x, oops, sorry about that, guys. Let me get rid of this. Sorry. So f of 0, we're going to have a negative 0 plus 3 quantity squared plus 1. 3 squared is 9, so a negative 9 plus 1, we're going to get a negative 8. So our y-intercept is negative 8. Lastly is vertex form, and that is what the main topic of 4.2 is about, is vertex form for our quadratic equations. And vertex form is, we already have it here, is our f of x is equal to a negative x plus 3 quantity squared plus 1. And in our next section, that's what we're going to speak about. So as we move on through the notes, let's talk about vertex form. So our quadratics, we've seen in standard form, the ax squared plus bx plus 1. And reminder, we know it's a quadratic because of our x squared here. And we know that our a term has to be something that is greater than 0. Otherwise, or it cannot, it cannot equal 0. Because if it were to equal 0, then we would not have an x squared term and we would not have a quadratic. And we're going to take our standard form and we want to switch it into vertex form. So if we think about our equations of our lines, you can have an equation of a line in standard form. You could have it in point slope form. You could have it in slope intercept form. They're all the same graph. They're just the equations. The terms are kind of moved around into different positions. And in different forms, we get different information about that particular graph. So vertex form, standard form represent the exact same graph. They're just different ways of having the terms. So with our vertex form, we know that our parent graph is that x squared, that basic graph. This h, anything that's been added or subtracted to the x, we know would shift our graph, translate our graph right or left, depending on what that number was. This k term outside here, we know anything being added or subtracted outside would always shift our graph up or down. If this a outside here was negative, we know that would flip our graph over the x-axis. And so we're going to be looking at those different numbers very specifically. So our vertex, that turning point, is always going to be that hk, how we've translated it left or right, or how we've translated it up or down. Our axis of symmetry, that line that cuts right through the middle of our parabola, that vertical line, is always going to be our x equal to h. Our a term, that term that's outside the parenthesis, well, if a is a positive number, we would not reflect our graph over the x-axis, so our graph would be going upward. If our a was a negative number, then we know that we would flip over the x-axis, so our graph would be opening downward. And just for, in terms of our a value, if it's something else, absolute value of a being greater than 1 or absolute value of a less than 1, if a is a number greater than 1, then our y values are getting larger and larger faster, which means it's going to narrow our parabola. We're going to have a skinnier parabola versus if we have some sort of fraction in there, less than 1, a 1/2, a 1/3, 1/4, our y values are not getting large as quickly, and so our parabola is going to be much wider. Okay? So let's look at number 2, looking at the fact that our quadratic here is in vertex form. It is in that form of f of x equaling our a, x minus h quantity squared plus k. So when it's in our vertex form, we know that our vertex, that turning point, is our hk, and in this particular case, our vertex is that 7, 2. And because our a term is a -3, because our a is less than 0, it's a -3, we know that our graph is going to be opening downward. So in terms of our graph, our vertex is at the 7, 2, and it's opening downward, so it's going to be looking something like that. For our domain, we know that we have no restrictions. It's going from a -infinity to infinity. We can plug anything in for x. Our range, our y values, are going from a -infinity up to 2, including our 2. Our min value is going, does not exist because our graph is going down towards a -infinity. Our max value, our largest y value, is the 2. Interval increasing, where's our graph going up? Our y is getting larger as we move across the interval from a -infinity to a +7. Interval decreasing, our graph is going down. Our y's are getting smaller as we move across the interval from 7 towards a +infinity. Our axis of symmetry, that line that cuts right through the middle of our parabola, that vertical line, and a vertical line is always x equals to the x of the point. So in this case, x equal to the x of our vertex, x equal to 7, x equal to the h. And x-intercepts, we know for x-intercepts, we always set y equal to 0. So our equation here would be 0 is equal to a negative 3, x minus 7 quantity squared plus 2. Bring our 2 over, and we're going to divide by the negative 3 and take the square root of both sides. We're going to get our absolute value. I'm going to rationalize the denominator right away, root 6 over 3. And because of the absolute value, we would get plus or minus the root 6 over 3 equal to x minus 7, and then bring our 7 over. So we have two x-intercepts. I'm just going to put them over here. 7 plus or minus root 6 over 3, comma 0 for our x-intercepts. And y-intercepts, we know that we always set set x equal to 0. So when we set x equal to 0, we're going to have the negative 3, 0 minus 7 quantity squared plus 2. So we have, what, 49 times a negative 3, doing some math over here to the side, a negative 147 plus 2, we get a negative 145. So our y-intercept is the 0, negative 145. Okay. B is very similar, so I'm going to let you work out B, and then we will come back for the next